Hey, what's up, guys? Chung here again. So today let's talk about this LeetCode problem number 1477. Find two non-overlapping subarrays, each with target sum. Okay, so you're given like an array, and keep in mind that all the elements, all the number in the array is positive number, and then a target sum here. You need to find two non-overlapping subarrays whose target sum is exactly equals to the 3, right? And then you need to return the minimum sum of those two non-overlapping subarrays. All right, so you need to get first, right? First you need to get the sum of subarray. Then you should immediately come come up with a pre-sum 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 or the rolling sum, right? So that you can easily calculate the subarrays uh, sum, right? And then the second one, the tricky part of this problem is that you need to find two, right? You need to find two non-overlapping subarrays. So let me zoom in the problem a little bit. So for example, if you have this long array here, right? So the idea here is that every time, right? Let's say if you find like a current subarray, right? If it's from I and j, let's say from I and j, for I and j here, we have a we find a subarray, okay, and whose sum is equals to this target here. And then how can we find the what is that? The other subarray, right? So there are two ways actually, and you can either look forward or look back, right? But to both look forward and look back, you need somehow to store that information, right, somewhere. So in my case, I decided to look back, and to look back, basically, so from looking back here, I uh, I need to somehow find from zero to I, right? From zero to I minus one is what's the basically what's the minimum if there's a subarray whose target equals to 3, and I need to find the minimum among all of them, right? So that will come with like a dynamic programming idea here. Basically, every time when I reach the new index here, I always keep the current shortest sum whose length, sorry, whose sum equals to the target, right? And now every time when I see a new subarray whose target sum, I go to look for its dp I minus one. I will check if dp I minus one st stores any any value, right? Basically, if there's any value, then it means okay, from 0 to minus I minus 1, we find there was like a subarray, right? Because remember we stores the we saves the minimum value in this dpi minus 1, right? So that's why we can find that, and we keep moving we keep moving the basically the second array forward, right? And every time when we find a new secondary secondary subarrays, we'll look back to check, okay, if there's anything in this DP uh, I minus 1. Uh, okay, so let's try. Okay, and then we can try to code. And oh, another thing way is that we can also use a hash table to find the uh, basically a hash table will be from current position and the current sum minus the target. We will see, okay, if there's any previously sum that can give us the target, right? That's another way of doing it, but in my case, I'll just use the DP array here. So okay, cool. So let's try to code these things, and I'm gonna create a DP system max. So the reason I use the system max here is because since we need to find the minimum subarrays on each position here. That's why I need to have like a maximum value here, right? And then we also have a left, right? Left and right. Answer equals to 0, and then I'll be having I'll use a for loop to I'll use a for loop to loop through the right counter. So num enumerate array here, right? And then basically mm, oh, since I'm going to use a running sum here, right? Also running sum equals to 0, right? So first running sum plus num, right? And then I check if the running sum is a valid or not, right? Basically, while running sum is greater, right? It's greater than the target, right? Then we will shrink the running sum, right? We'll try to shrink the running sum until it's within the target range. Sum and left, right? Then left plus 1, right? And then if the running sum is equal, right? Is equal to the target, right? Then we check, right? Check if the DP left minus 1, right? Left greater than 0 and DP left minus 1 is smaller than the system max size, right? So if that's the case, we find the answer here, right? Basically, the answer equals will be the one's minimum answer dot dp left minus 1, because the dp left minus 1 stores the previous subarray's minimum length, right? The first one, and plus the current one, right? Minus left plus 1, right? So that will be the final, will be the answer here. And then and we'll also be maintaining like the current shortest, right? Shortest of array here. And this is also gonna be the system maximum, right? Max size. So minimum, right? Dot, same thing here, right? Every time we have a valid arrays here, since we're going to use this DP for the future calculations, and that's why for each of time we have a new matched subarrays, we'll update the current shortest shortest subarray, so that in the end we'll be updating this DPI with this shortest right? Then in the end, we just return the answer. Yeah. So this should just work. Sorry, left. DP left. Okay, not DPI. Hmm. Uh, answers. Oh, sorry. So here, yeah, since we're getting the minimum here, we need to do a maximum here. And if answer is smaller than the system max size, right? Else just a -1, right? Hmm. Let's see. Um, yeah, I think here should be right because we're updating the current index, not the left pointer one. So let's run it again. All right, so this time it's passed. All right, so a quick recap, basically, and since we need to find two subarrays, right? So and that's why we have to somehow find a way to maintain for either the first array or the second array, right? And in this case, I'm maintaining the shortest path for the first array so far we have seen so far, and then that will be saved in the DP. That's why every time when we see the new subarray, right, we'll check this left -1 will make sure it's not overlapped. It's not overlapped uh, array, right? So every time when the right pointer, when the right we find a new subarray, right? A new shortest subarray because we'll be moving this. We'll be trying to move this left pointer, right? Until it finds a new match, right? Because the sum is always increasing, right? So in order to find a matching a matching sum, we have to move the left pointer to the right. Otherwise, this running sum will keep increasing, right? That's why we need to shrink the left until it could be inside the target range, and then we check if this equals target. We'll try to check if there is any there's a first array have ever been seen had ever been seen before, which will be saved in this DP array. If there is, then we update our answer, right? With our current array's length plus the first one. And then while doing that, we'll also be maintaining the current shortest one to save into the DP right to set storage in the for the future use. And cool, I think that's pretty much it is. I think there's other solutions for this problem, but I think for this one I'm just using a sliding window plus DP. Cool, thank you so much for watching the videos, guys, and stay tuned. See you guys soon. Bye bye.